Vector algebra. This chapter carries 11 marks in your final exam. So let us understand what vector algebra is. So before actually knowing what vector is, let us understand which quantities are called as vectors. So here you can see three lines here. So if I consider a line in a space or in a plane, so a line can be directed in any way. So here if any line has got an arrow, either it can be upward or downward, then such lines are called as directed lines. Means the lines with any of the directions prescribed will be called as directed lines. So you have these two lines, the first two lines are directed lines. In the same way, if you see the third line, in this, the line has got its direction. And what we have done is, I actually cut this line and I have taken only the portion of reference. In the line, I have taken only a line segment, that is from A to B. So when I take a line segment, by this, I'll even be knowing what is the length of the line, which we call it as magnitude of the line. Okay? So, in the third line, if you see, I've got the direction and also I'm able to find what is the length of the line segment AB. So, any quantity which has got both magnitude and direction, such quantities will be termed as vectors. So, a quantity which has magnitude and direction is called as vector. So a quantity that has magnitude and direction is called as vector. So this is an example for a vector. Since I have taken a line, so this is a directed line because the arrow is helping us to show the direction of the line, and in this line, I have cut the line since I have taken only the portion of the line. This is a line segment. So when I take only the portion of the line, so I can definitely know what is its length. It is nothing but the magnitude. So the quantity, a quantity that has both magnitude and direction is called as vector. Whereas the quantity which has got only the magnitude will be termed as scalar. So if I take this line segment, so this is A, this is B, and this is directed like this. So this is called as magnitude. Magnitude is nothing but the length, that is the distance from a point A to a point B, where the point A will be called as initial point and the point B will be called as terminal point. Okay? Initial point from where it is actually starting, terminal point from where it is ending. So here, so you have the directed line and the magnitude. So this is called as vector. How to represent this vector? Vector will be represented in this form. Vector A, it is as vector AB. When I write it like vector AB, it says that the initial point is A and the terminal point is B, and it is directed from A to B. If I write it like BA, vector BA, then what it says is, this is a vector whose initial point is B and the terminal point is A, and it is directed from B to A. Or we even represent as vector A, small letter vector A. This can also be represented as small letter vector A. Not only small letter A, it can be with any small letters. Okay? So this can also be written as vector B or vector C. So this is the representation of the vector. So if vector is represented like this, how do we represent the magnitude of the vector? Magnitude of the vector will be represented as magnitude of vector AB. Don't read it as modulus, magnitude of vector AB, or we write it as magnitude of vector A. It is compulsory you should write this vector symbol. For magnitude, we even write it as A. Okay, it is understood because magnitude doesn't require any direction. So we just write it only A when we write magnitude. Or else it is better to use this symbol for magnitude, and this is the representation for vectors. So I define again what vector is. You can make a note of it. A vector is that quantity which has both magnitude and direction. Let us now study different types of vectors. So under the first one is zero vector, or it is also called as null vector. So zero vector or null vector is a vector whose initial and terminal points coincide is called as zero vector. A vector whose initial point and terminal point coincide is called as zero vector. Okay, it is denoted by this denoted as zero vector. Okay, so when you have initial point A and even the terminal point is also A, so initial and the terminal point coincide, such vector is called as zero. What will be the direction of the zero vector? The direction can be any direction in case of zero. So next is unit vector. Very important. Unit is one. So a vector whose magnitude is unity is called as unit vector. A vector whose magnitude is unity is called unit vector. So the vector in the direction of the given vector, the vector can be direction of the given vector is given vector A is denoted by, the unit vector is denoted by A cap. The unit vector will be denoted by A cap, and it is defined as A cap is equal to vector A divided by magnitude of vector A. This is very important, students. So unit vector is a vector whose magnitude is unity. So how we find that? If we need to find the unit vector of a given vector, we should write the vector in a given direction divided by magnitude of the vector. Means the whole vector. Means the vector means you have given magnitude as well as direction. If that vector is divided by its magnitude, then we get a unit vector. Okay, so this definition you should remember. Next type of vector is co-initial vector. So as the name suggests, two or more vectors having the same initial point is called as co-initial vectors. So two or more vectors having same initial point is called as co-initial vectors. Means if you have any vectors which are starting at the same point, two or more vectors starting, say the starting point of both or more than two vectors are same, then we call those vectors as co-initial vectors. Next is collinear vectors. Two or more vectors are called collinear vectors if they are parallel to the same line, irrespective of their magnitude and direction. Okay, so collinear vectors are those vectors which are parallel to the same line, whether their direction and magnitude may differ. Then also they will be called as collinear vectors. Next type of vector is equal vectors. Two vectors, vector A and vector B, is said to be equal if they have same magnitude and direction, regardless of position of their initial point. If the two vectors can start with anywhere, means both the vectors do not have, may have or may not have the initial point as same, but the magnitude and direction of both the vectors should be same, then we call those two vectors as equal vectors. Next vector is negative vector. So it is defined as a vector whose magnitude is same as the given vector, but direction is opposite to that of it, is called as negative vector of a given vector. So the vector which has got same magnitude but opposite direction is called as negative vector. So here we have studied different types of vectors. I have given you even the definition. So this definition they may ask for 1 mark in your final exam. Next you have a concept called free vectors. Okay. So what is the free vector? Actually, I can displace any vector if I am able to subject it to the parallel displacement without changing its magnitude and direction, then such vectors are called as free vectors. The above means if the types of vectors which we have already studied, all those vectors can be subjected for free vectors. For example, let us say, let this be a vector A, and somewhere here let this be a vector B. This two vectors I can shift to any place by actually not changing its magnitude as well as direction. With the same vector, I can write it down without changing its magnitude and even direction. So parallel displacement, and even this vector, I am shifting here again without changing its magnitude and direction. This we will be using. So this concept of free vectors, it is understood that any vectors can be displayed how parallel without changing its magnitude and direction. So with this, let us solve few problems, basic problems related to the concepts which we have studied, that is related to the definition of the vector and the types of vectors. So here I have given represent practically a displacement of 40 kilometers 30° east of north. So let us first write this will be a north, south, east, west. So they are telling that 40 kilometers 30° east of north. East of north 30°. This to be this is 30°. 30° east of north. So this I take as 40 kilometers. Roughly you should write. Okay. Next. Classify the following measures as scalars and vectors. We know that a vector is a quantity which has got both magnitude and direction. But as scalar, it has got only magnitude but no direction. So 10 kg, if I say 10 kg, whether this is a scalar or a vector, definitely this is a scalar. It is 2 meters northwest. So here if a person is traveling, if I ask someone to travel 2 meters in the direction of northwest. So here 2 meters is the magnitude, northwest is the direction. So this definitely is a vector. Next 40°. If I say 40°, there is no direction. This is just a magnitude. Again it is a vector. Then 40 watt. Again this is 40°. There is no direction. So this will be a scalar. Again you have 40 watt. Again this is a scalar. 10 to the power minus 9 coulomb. Remember it is a scalar. 20 meters per second square. So it is distance traveled by time taken. It is a speed. Okay. So speed. Again this is a vector here. Total distance traveled by time taken. Therefore, this is vector. Okay, next, again, they have asked us to classify the vectors and scalars. Time period, it is a scalar quantity. Okay, distance, it is again a scalar quantity. Here you have, the distance, only the magnitude, but here we exactly don't know in which direction they have covered that distance. So it is a scalar quantity. Force, it is a vector quantity. Force, mass into acceleration, vector quantity means you are applying some force in some particular direction. If I ask you to push a desk, so you may ask, in which direction should I push? So again, the force is mass into acceleration, a vector quantity. Velocity, again, it is a vector quantity. Displacement by time taken. Okay. Next, work done, it is a scalar quantity. Next, they have asked us to identify the following vectors with the help of this figure. First, they have asked us to find what are co-initial vectors. In this figure, we need to recognize which are co-initial vectors. As the definition says, the co-initial vectors are those vectors which have the same initial point. So, which two vectors or three vectors which have same initial point? If you see vector A and vector D are starting with the same initial point. So, the co-initial vectors are vector A and vector D because they are starting at the same point. Next, collinear but not equal. Collinear vectors are those vectors which are parallel to the same line. So, if you see this vector A and vector C are collinear. Even vector D and vector B are collinear. But they are collinear but not equal. When you come to equal, then those vectors which have same magnitude as well as direction. Here B and D have same direction. Though they are collinear, but they are also equal vectors. We need only collinear and which are not equal. So vector A and vector C are the vectors which are collinear and they are not equal. Why they are not equal? Because they don't have the same direction. Next, they have asked us to find what are the equal vectors. So, what will be the equal vectors? B and D. B and D are even collinear, but they are equal. So, here B and D are equal vectors. Unit vectors along coordinate axis. Okay, we already know what is the unit vector. A vector whose magnitude is 1 unit. So here, let us consider 3 points A, B, C on x, y and z axis respectively. So if you see, the distance or the length from O to A is 1 unit, the length from O to B is 1 unit and the length from O to C is 1 unit. That is, if I take this as a vector, the vector OA has the magnitude of 1 unit, vector OB has a magnitude of 1 unit and vector OC has a magnitude of 1 unit. Therefore, I can call vector OA, vector OB and vector OC as unit vectors. So, since these vectors are represented on x, y and z axis respectively, so a unit vector along x axis will be always represented as I cap. So the unit vector along x-axis will be always represented as I cap. Similarly, on y-axis, the unit vector along y-axis we always represented as j cap, and on z-axis we always represented as k cap. So the unit vector along the x-axis is I cap, along the y-axis is j cap, and along the z-axis is k cap. When we tell I, j, k cap, this is understood. They are the unit vectors of x, y, and z axis respectively. Okay. What is this position vector? Position vector is nothing but representing the location of the point through vectors. Okay. We all know that how to represent a point in a coordinate axis. If I tell 2, 3, then we know that we are moving along x-axis of 2 units and then y-axis of 3 units. So here if I take P of x comma y, means I am moving along x-axis of x units and along y-axis of y units. So how to represent this in the vector? See here I am moving x units along x-axis. So along x-axis, what is the unit vector? It is I cap. So x into I cap. Then after this, I am moving along y-axis of y units. Therefore, y into j cap, because j cap is the unit vector along the y-axis. This is the displacement or the final displacement of the vector OP. That is, from the initial point to terminal point O to P, I have traveled so much distance. So xi plus yj cap is equal to vector OP. I repeat again, x into I cap. See, I cap is the direction in which we are moving. X units we are moving in the direction of x-axis. That is why I cap, because I cap is the unit vector along the x-axis. Again, y units we are moving in the direction of j cap. That is, the unit vector along the y-axis is j cap. Therefore, the total displacement. What is the displacement? Displacement is the shortest distance traveled, right? So O to P, the shortest distance traveled is xi plus yj cap. Now let us find what is the magnitude of this vector. So OP vector, I can even represent it as vector R. Here the OP vector is called as a position vector by because when I say position vector, always in the position vector, the initial point will be from the origin. whenever we say position vector, the initial point of the position vector will be always from the origin. Now let us find the magnitude of this position vector. So if we want to find the magnitude of this, so if you see, you have a right-angled triangle here, right-angled triangle. So if I apply the Pythagoras theorem, definitely I will be able to find the length from the point O to a point P. So here you have x and y. If I apply Pythagoras theorem, I will get it as root of x square plus y square. So this is the magnitude of the vector OP. This is discussed or find the position vector in 3D. So you have the point P here. For this point, for this position vector OP, let us find what are the components or what is the position vector OP can be written as. So here, in normal, if this is in coordinate axis, if I take P of x, y, z, means it says that we are traveling a distance of x units along x axis, y units along y axis, and z units along z axis. So in vector, how to write this? So this point P, first we are traveling the distance of x units along the x axis and in the direction of x. So it will be x into I cap. First, the number of units you are traveling is x. X can be any number, either 2, 3, 4, 5, any number. In the direction of what? In the direction of x axis, so x into I cap. In vectors, we know that magnitude as well as direction is important. So x into I cap. Then after that, what I did? I traveled a distance of y units. So from here, I traveled a distance of y units. So you can see this. See, this and this is same. They are parallel and equal. So I have traveled. So this I can write it as y into j cap. So next I have traveled a distance of y units in the direction of y axis. So j cap. Next plus after this from here to here I need to reach. So this is along which axis? Z axis. So this will be z into k cap. I have traveled a magnitude of z in the direction of z axis, so z into k cap. So this is the position vector of vector OP, or this can be written as vector R in 3 x, y, z. So xi cap plus yj cap plus zj cap. Then let us see how to find the magnitude of this position vector. In 2D space, then directly you can see a right angle theorem. Right angle triangle. You can apply the Pythagoras theorem and find the magnitude. In this also, with the help of the same theorem, let us find how to find the magnitude. So if you see, I can draw a triangle here. So you have a triangle OQP. Again, this triangle is a right angle triangle. Okay, here at this point is 90 degrees. So this is 90 degrees. So here we need to find this distance. We need to know this distance. This is x, this is y, this is hypotenuse here. So here hypotenuse is this OT is nothing but OT is equal to root of x square plus y square. So using the Pythagoras theorem, if you see the triangle OQT, this will be OT is your hypotenuse. So you can find the hypotenuse. The hypotenuse will be equal to root of x square plus I square when you apply the Pythagoras theorem. Next, so if you see the next triangle OTT, again this is a right angle triangle. So with the help of this triangle, we are able to find what is OP. So here OT we found there is nothing but root of x square plus y square, and TP it is z. Why? Because TP is same as OR. So if we apply the Pythagoras theorem, OP will be equal to root of x square plus OB square is equal to root of x square plus y square plus the whole square plus z square. So this when we simplify x square plus y square plus z square, therefore OP will be alone equal to root of x square plus y square plus z square. Therefore the the magnitude of the vector OP is given by root of x square plus y square plus z square. The position vector is OP and it can be written as x I cap plus y j cap plus z j cap, and the magnitude is root of x square plus y square plus z square. So any vector in this form, okay, is called as component form of a vector. The vector of this kind is called as component form of the vector. In this, x, y, and z are called as scalar components, and xi cap, yj cap, zj cap are called as vector components. Okay. In today's class, we have seen definition of vector and types of vectors, and also the position vector in 2D and also 3D.